The last part of test the revision electricity, we're analyzing, we're comparing series circuit with parallel circuits. So there are two types of circuits we're analyzing. Now, the main difference between them is that the series circuit will only have one loop. So everything goes through one loop. Everything is situated in one loop. Everything is put together in one loop. That's it. While a parallel circuit will be made of two or more loops, so it will be made of multiple loops. Okay, one of the main characteristics of a series circuit, if one device in this circuit, any device, is that maybe it can be an ammeter, it can be the first bulb, I'm just putting this example out, the second bulb, the third bulb, or the switch. If one is off, everything is off. On the parallel, on the multiple circuit, if one device is off, the other ones work. Now, if the ammeter is off, everything will be off because there is no way to go through. But any one of these bulbs, if it's off, the current will go through the other one, so the circuit is still working. Okay. For example, we have a battery or battery cell of 6 volts that gives energy through the circuit. This would be like, so all bulbs get the same current, as we discussed it in class. For example, if there are 6 volts available, 2 volts for the first bulb, 2 volts for the second bulb, and 2 volts for the third bulb. That means, we can put it like this, like one chocolate is broken in three parts. Okay, so because the current is broken for each one separately, the bulbs will be dimmer than if they would be working alone. So for example, if I have a 6 volts battery working with only one bulb, let's say these two are out, then this bulb will be much brighter. When I'm adding a second bulb in the circuit, the bulbs are getting dimmer. If I'm adding the third bulb in the circuit, the bulbs are getting even dimmer. Think about the experiments we've done in class. So for example, but the current is the same. So at this moment, for example, this battery manages to get out 1 amp of current. That means the first one gets 1 amp, the second one gets 1 amp, the third one gets 1 amp. So the current, if it's 1 amp, everyone gets the same current. That's why the brightness, in the case the bulbs are the same, the brightness will be equal for each one of them. The voltage from the cell is shared. That means all bulbs get the same current, the one chocolate for all of them. So that means if we have a voltage of 6 volts, that will be broken down in 2 volts for the first one, 2 volts for the second one, and 2 volts for the third one. So the first one gets 2 volts, it gets 1 amp of current. The second one gets 2 volts, it gets 2 amps of current. The third one gets 2 volts, it gets 1 amp of current for the second one, 1 amp of current for the third one with 2 volts. In parallel, multiple loops, which means that every bulb gets the same voltage from the cell. So if in a series circuit, we've seen those 6 volts are shared between the bulbs, 2 plus 2 plus 2. Here, everyone gets the same. So the voltage is the same. So 6 volts, the first one gets the 6 volts, the second one gets 6 volts, the third one gets 6 volts. Obviously, they will be much brighter bulbs than when they were positioned in a series, because you see the amount of current going through is much larger. So for example, if there are 3 amps going through, the first one gets 1 amp, the second one gets 1 amp, the third one gets 1 amp. There is much more voltage going through. In this situation, if one bulb is off, the other ones will work. So the other ones will go through. Moving forward a little bit, we discussed during our last lesson, and we analyzed experimentally the short circuits. For example, if I have a circuit made of 2 bulbs in series, if I would add a wire like the pink one in the circuit, the current would choose to go through the wire rather than going through the first bulb, because the resistance is much smaller, so it's practically a much easier road to go through the wire than through the bulb, which means that all the current that was initially allocated to bulb 1 will go and will go through bulb 2, so that means bulb 2 will get much brighter. If I arrange the wire in the circuit, the lead, in such a way that the kind of cut off the first and the second bulb, well, both of them will be off, because at this moment the current just goes through the pink wire and goes back to the battery and over again. This causes the wires to heat up pretty fast, which is dangerous. If I'm doing the same thing, for example, if you look at position number 2 compared to position number 3, is pretty much the same thing. So I'm cutting the circuit off through the pink wire. I'm still providing a circuit for the current to move through. The current doesn't want to go through the wires because it's much simpler to go through it doesn't want to go through the bulbs because it's much simpler to go through the wires. That means the current will just move around in this small circuit, and then those bulbs will be off, will not get anything. In the case of a parallel circuit, the current goes. If I'm cutting out the circuit through the point where those two bulbs make connections with the main circuit, everything will be off because the current just chooses to go through the pink wire, and that's it. There's nothing going on to these bulbs. Now, if I'm only cutting off one bulb, when the current chooses to go through that bulb, a little bit will be able to go to the second bulb also, which will make this bulb a little bit dimmer. And if I'm doing the same thing, I'm cutting the bulb on the bottom and I'm doing the bulb on the top to work. The bulb on the bottom will be off because the current goes through the wire. It doesn't go through the bulb anymore. And from the main current, a little bit will choose to go. We'll be going through the wire through the bulb on the top. This will be very, very dim. So in a conclusion, we discussed a little bit about short circuits here. And we've seen the difference between series, which is one loop, and parallel multiple loop circuits. In series, everyone gets the same current, but they share the voltage. In parallel, everyone gets the same voltage as the cell has, but they share the current. And this is it. Wish you good luck for the test. Thank you.